Hi guys, I'm gonna challenge 1833 maximum ice cream bars. Start timer. It is a sweltering summer day. What the? Sweltering. Okay. Boy wants to buy some ice cream bars. At the store, there is n ice cream bars. You're given an array cost of length n. Where cost I is the price of ice cream bar in coins. The boy initially has coins to spend, and he wants to buy as many ice cream bars as possible. The boy can buy the ice cream bars in any order. Return the maximum number of ice cream bars the boy can buy with the coins. We must solve this problem by counting sort. Okay. So which means that coin 7 out of 4. 1 3 2 1 1 1 2 3, which means 1 1 2 3 is 4. And then 5 does nothing. 20 1 1 3 1 1 2 3, something like that. So we need to use the counting sort, and the cost length is n. N is pretty large, and then cost I is this much. So this is pretty large, okay? And coin seems to be very large. 10 8. Is it beyond the integer? I'm not sure. Let's first stick to the integer. So normally what we can do with the count distribution is that we need to minimize the number of the array. So we can first search the minimum, and then we can search the maximum. So for each, let's say that there is a int min and cost, and which is the numeric limits. Int min max, and then max is, let's set this to small number, min, but here cost is defined as this one, so we can set it to 1, and we can set it to minimum to the largest one, 1 2 3 4 5, right? So for each cost begin and then, so we're gonna pass min cost, and then max cost, then int cost. So what we're gonna do is, if we're gonna do two things. So we're gonna find if cost is smaller than min cost, then let's add min cost to cost, and so it's larger, So now we know the min cost and max cost. So distribute counting sort. So we're gonna count cost, sorted cost. So the number is max cost minus min cost plus 1, and you're gonna set it to 0, which is invalid number. Okay, and then what you're gonna do is that we're gonna have some loop for int c. This is cost, where from cost, and then we're gonna increase this number to cost, but cost, so cost is normalized number. So for example, like if min cost is let's say that if like max cost is 100 and min cost is 10, then we're gonna have let's say that 2. We're gonna have 3 array, and then array 10 actually means we can calculate like this, right? So we're gonna do min cost. We're gonna do something like this. That way we'll have sorted array. So next thing we're gonna do is we have coins, right? So coins should be, so while coins is larger than or equal to 0, and then what we're gonna do, and then we need to what will be the answer? The way return the maximum number of ice cream. So ice cream is initially 0, right? So so what we're gonna do is let's do this with 4 int we don't need int int cost, not cost. We need I cost. Normalize cost is 0. Oh shit. And then this is smaller than sorted cost length. And then I'm gonna increase normalized cost, and then we'll have the real cost, right? The cost is normalized cost plus min cost. Yeah, so that's in this case normalized cost is 1, right? And then we need to get 11 by adding the minimal cost right here. So something like that. So now we know the cost, and then count count is 30 least plus normalized cost, right? So so here let's say we're gonna return this one. So let's say the coin left so here so let's say that the cost is 10 and we have like cost is 11 and then count is like 4, then we have 44, and then coins, the left coins is for example like 50. So what you can do is you can divide 50 with 11, right? And then this value is same with 4, same or larger, like for example 56, same or larger, then we will go to the next. But let's say that coin is 33, 34, and then this is 3 divided by 11 is 3, so we can just add 3 more. So int how many can we add? So this means this is like coins and then cost, okay, and then so what you can do is if how many is 0, then we can just break, and then if how many host, and then if how many is count is larger than count, then we're gonna add, so we can add a lot, right? So ice cream should be count, and then coins should be how many coins should be cost count. 정아 문 닫아줘. Else, and the next case is how many is smaller than count, right? Which means that this is the last turn. So in this case, we can how many add this and break, right? Here we can change the order, and then if count 0, then continue. How many 0 coin? Somehow we don't have not enough coin. So in the case, we'll just return, and then we're gonna return 0. How many is larger? Then we can count. We can add count, and then we can subtract this one. And if how many is smaller, then we'll get this much, and then there is no need to go further, so we'll break. Yeah. So let's do some checking. For example, this case. So in this case, for this case, we're gonna have so 0, 1, 2, 3, 4, 5. How many? 1, 2, 3, 4, 5, 6. Right, this one, and then no, and then actual value and normalized value. Actual value is actually 6, 7, 7, 8, 8, 10, right? Normalized value is here. We're gonna do this min cost. Min cost is currently 6. So 6. So 0. Yeah, this is normalized value actually. 0, right? And then count 1, no. So there is 1, 7. So 6, 10. 10 minus 6 is 4, and so we're gonna have only 5. So we're gonna have this, and then 6 is only 1, and 7, 2, 8, 2, 9, 0, and 10, 1. So this is the value inside the counting. And then so here what you're gonna do is coin is currently 5, so we have coins, which is 5, right? And inside this loop we're gonna sort this one, sorted cost length. So normalized cost, which is this one, 0, and then count is not 0, then cost is 6, still 6. So we're gonna try to divide 5 by 6, which is 0. So we're gonna break, right? And let's say we have 6 plus 7. Let's say we have 7. So here, how many is currently equal to count, right? Count is 1. So we're gonna add ice cream to 1, and coin is currently left to 1. Okay, and then next turn, this will be 0, so we'll break. So what if we have what if this is 2 and then we have 7? In the case here, how many is coin cost 7, and cost how many is 1, right? And then this case, right, how many is smaller than count, which is 2? So ice cream, we're gonna add a 1 and break. And if we have like 13, then we're gonna be here. Then this one is 2, ice cream will be 2, and then coin will be 1, and then in the next round, coin is 1, cost is 7, so yeah, how many will be 0? So let's run this. Line 22, compile error. Sorted length size. Count. I always write coconut. Run. Cool. Submit. Cool. And my solution is kind of fast, but the memory consumption is like 78 somewhere. Not bad. Maybe this one is not critical, I guess. Yeah, still I don't know why it takes this memory. You might be using global static variable C++. What? Runtime error? What is this? Address sanitizer failed to allocate. Sometimes it fails. I don't know. This value is within the limit of the integer, right? Let me try once more. I don't use any global variable. Oh, we might be using global static variable or while trying to map too long byte. I understand. So the problem is that I don't know what is the problem. This, well, the minimum is one cost length. Coins is larger than cost 0, then 1. This might not be the problem. Maybe there is some random. Let's read. If I encounter wrong answer, count error for a specific type. When I test my code using this thing, I produce code. But culprit causing out-of-bound array access the bug could be hard to debug. So good luck. I just give up on predictable language. While trying to map FFF1 byte. First, you're using ulimit fee. What's ulimit fee? I guess this error was caused no answer. This thing goes out of RAM. Here is a snapshot of the system manager. Memory. Oops. Oops. Probably he's doing some loop. I don't know. But anyway, it seems that this is too big, right? So I might need to max. This is weird. So here mean cost is very large, so mean cost, this one will be the mean cost. Here max cost is 1, and then the next time max cost is 3, so 3 is more than 1, so we'll add max cost. So here mean cost and max cost. Yeah. Here let's try this with a 7. Oh, this is the case. So which means that if I run this again and again, this is weird. Here I don't use any static variable, and I don't know why it happens. In the real case, when this keep happening, I probably need to check this. This is the only thing inside the stack. Okay, so solution editorial, let's see the sorting greedy, counting sort greedy. To be honest, yes, it is an easy problem solving without sorting. So the time complexity for this problem, yeah, this one's not very difficult. Then here is vector max element. Oh, max element. Yeah, I knew this. Mean element and max element. But I also want to try the mean element, so this is why. So this code is actually this code 0 and smaller, larger. Pretty similar. Okay, so let's finish this.